Okay,
Yes, sir.
we come to the last application of free surface, of moment of inertia, and that is in free surface, moment of inertia of the free surface. Now, for this, you need to recall your concept of FSC, FSM, and application of FSC to GM and KG. We can quickly have a recall of it. We all know what is free surface correction. We know free surface correction is FSM upon displacement. Correct, guys? Or any doubts on that? Is that correct? Or anybody has any doubt
Correct,
on
sir.
that?
Correct, sir.
No,
Correct.
correct, sir.
Okay, then how do you get FSM? You get FSM by multiplying something called as I with the density of the liquid. I'm sure
Into
you guys
the
also, yeah, correct.
yes,
What
yes,
is this I which you have been picking from the MV heat shift tables? This I is the moment of inertia. Again, now the your question would be, why are you stopping at moment of inertia? You have not told us which area, which axis. This I in this FSM, the moment of inertia of the free surface. So which area? The area of the free surface in the tank. Okay, the free level with the free liquid level surface, whatever is the area, if it is rectangular, it is rectangular, if it is triangular, it is triangular, if it is circular, it is circular, if it's curvilinear, then it's curvilinear. So it is the moment of inertia of the free surface. And about which axis? About fore and aft axis through the geometric center of free surface. I'm not saying water plane this time. I'm not saying center of flotation. Geometric center of the free surface. So that means you'll have to identify the shape of the free surface. You'll have to figure out its geometric center. And through that geometric center, you will draw a fore and aft axis. Okay. Now this is the axis drawn through the geometric center of the tank. Whether it coincides with the center line of the ship, does not coincide with the center line of the ship, doesn't matter. Okay, because we are talking of a wing tank. Obviously, the fore and aft line will never coincide with the center line of the tank. So please be very clear what I'm saying. I said it is about fore and aft axis through the GC of the free surface. Is this what I have written here clear to everybody, guys? What is I? Any questions on it?
Yes, sir. Clear, sir.
You have yesterday visualized the shape of the water plane, and today you'll have to visualize the shape of the free surface. Right? In the first application COP, you were visualizing the shape of the immersed area. You see, in COP, the area involved was the immersed area. In VM, it was the water plane area. And in I of the free surface, it is the shape of the, it is the area of the free surface that has to be taken into account. Am I clear now? When you look at all the three, I think it becomes absolutely clear in your minds as to what we
yes,
have
sir.
done and what we're going to do. And then, of course, application of FSC to GM, we all know KM P minus KG is GM solid, minus FSC is GM fluid. I'm sure all of you know it, right, guys? This all of you know. I don't think this needs any discussion.
No, sir.
Okay, fine. And lastly, what do you mean by fluid kg? All of you have done GZ curves. In GZ curves, you are taking corrected kg, or that can also be called as kg fluid. And how were you obtaining it in GZ? You were adding the free surface correction to kg. I'm sure all of you can remember from your phase one. This you were using in drawing of the GZ curve, right, guys? So kg fluid will be equal to kg. When we say kg, by default we mean kg solid, and you have to add FSC. recap so that we don't struggle. Whatever I've ticked is just a quick recap, correct, guys? And what I have just added is what is this small I out here? This is the moment of inertia of the free surface about a 4.5 axis passing through the geometric center of the free surface. Any questions on whatever I've written and said so far, guys? Any questions, Bacho?
Sir, can you explain by diagram what is free surface, sir?
You have a glass in front of you. You have a glass at home. If you have a
Yes.
glass at home,
Yes, sir.
if you fill up the glass half, what will be the shape of the free surface?
It will be, sir, circle.
So why are you asking me to explain it?
Okay, sir.
It's okay. Okay.
Okay, sir. Okay, sir. Thank you.
Yeah. Okay. If you have some other shape of the container, then it will be different, right? Okay. Is that clear to everybody, guys? What I've said, or any more questions?
No, sir. Okay.
Okay, very good. So then we get going with the numerical. See, that's why initially when you understand COP and do enough questions on COP, then the remaining applications is just familiarizing with the formula. That's all, and then applying it because application remains the same. The concept of moment of inertia does not change. The concept of theorem of parallel axis does not change. It remains the same. So introduce I in FSM. I have already done that. And now we come to this question. The free surface of a 4-peak tank is triangular in shape with 12-meter width and 15-meter length. If the 4-peak contains water of RD 1.005, calculate the FSM in the tank. Please draw the free surface. Now you are not drawing the water plane, you are drawing the free surface in the tank. As per the question, please draw the shape of the plane free surface in the 4-peak tank. Have you all done? Mark the dimensions appropriately. Done, guys? I am not drawing it. I want you to do it and lead. Done it?
Yes, sir.
Okay, very good. I'm sure you would have drawn like this. If not like this, then you tell me what is the concern. This is the length of the 4-peak tank and free surface, and this is the breadth of the free surface. Correct, guys?
Yes, sir.
Please mark the geometric center where you think is the geometric center of this free surface. Now I'm using the word free surface. I'm not saying triangle. I'm saying mark the geometric center of this free surface. I'm sure all of you would agree that the geometric center would be somewhere here. Yes or no?
Yes.
Correct, guys? Please draw a 4.5 axis through this geometric center. In case of 4-peak, it may be coinciding with the center line, but I don't want to write center line at all because this can be misleading to you. It's only for your. So instead of that, I'll call this axis always XX. XX may coincide with the center line, may not coincide with the center line. Am I clear about it? Correct, Vita?
Yes.
So FSM will be equal to, he says find the FSM. It will be I into DI. And look at this. How can I get I? I don't have to speak now. Can you tell me how do I get I in this case?
So for
I
two
about
triangles,
XX. Correct. I XX. Oh, now let me write like the way we have been writing. I XX of the free surface will be equal to twice into I XX of half of area. Correct, guys? Correct? This will be equal to, now 2 into, tell me, what do I cube and what do I multiply? Tell me, guys. I don't want to give you any hint. You are already on top of it.
12 into 15 cube.
Ah,
No, sir. 6
नहीं sir. नहीं sir.
6 into 15 cube.
6 into
12 cube होगा, 12 cube
15 into 6 upon 36. 12 upon 12.
PD cube upon 12. You want the moment of inertia of this triangle about this axis, guys. So this axis is forming the base. If this is the axis, then what is the height of the triangle? 6 meters. Yes or no? Correct.
Yes, sir.
Why so much of confusion, my dear? And FSM would be equal to 2 into 15 into 6 cube by 12 into the density of 1.005. Units of FSM would be ton meter. Ton meter. And see if the answer is coming 542.7 ton meter beta.
Yes, sir.
Yes,
Five
sir.
foot.
542. Okay, anybody has any questions on this one?
No.
Everybody is good with this question, guys? Any doubts? Why we have taken 15 as the base? Why we have taken 6 as the height? We have dealt with this. Hey guys, yesterday could you do that semicircle question, all of you? You could match the answer?
Yes. Yes, sir.
Yes,
Sir.
sir.
Okay, good. That makes my life easier. Then there should not be a problem. Okay, unless anybody has a question, I'll move on to the next one then. As every time we start with a simple one, and then we start little raising the bar a little bit. So this basically clears the concept of how to visualize the free surface, how to visualize its geometric center, how to draw a 4.5 axis through the geometric center, and then how do we get FSM. Okay, now look at this question, beta. This is a curvilinear one. A ballast tank is bound by the ship side on the outboard side, a longitudinal bulkhead on the inboard side. The breadth of the free surface in the tank measured at equi-spaced interval of 4 meters interval from forward are. This is my own question. So the idea is not to have too many ordinates or something. Idea is just to make sure that we are clear on the concept. Find the FSM of the tank when it is partly filled with seawater of RD 1.010. Now, let me give so that we have the similar diagram. Let us say, guys, this is the forward side of the ship, and this is the after side of the ship, so that all of have the same orientation. We don't create confusion. Now, can you draw the shape of the water plane, keeping top of the page as forward and keeping the bottom part of the page as aft? Now draw this free surface and mark the ordinates. I'm sure all of you can visualize this free surface. If you have doubts, even then, draw it in rough. Don't just keep sitting and looking at the board better. Because you cannot solve a question unless you can get the question right. Solution follows after understanding the question. So don't always try to follow the class. You need to lead the class. Has everybody drawn the water plane, whatever they thought of?
Yes, sir.
Okay, now I am drawing. If you are in agreement, fantastic. If your diagram does not match with mine, then if you feel that you made a mistake and you have understood the mistake, then fine. If you still feel that no, you have not been able to figure out, then let's discuss. Okay. So they are given from forward. So here is the center line. I'm drawing on the starboard side. If somebody has drawn on the port side, it's fair. That's not an issue. Because my hand usually works on I'm a right-hander, works on the right side. So that's why I'm keeping it on this side. But if somebody has done on the port side, it's perfectly fair. No issues about it. So that does not need any deliberation. Guys, is the diagram correct? Tell me.
Yes, sir.
Anybody who feels that he is not able to understand the diagram as per the question. This is the free surface in the tank. Clear? Don't bring me back to the shape after we make headway, guys. If you have a doubt, please ask as and when we are at that particular point. Okay.
Sir, it is possible we can draw to turn this drawing 90 degrees, sir.
You can draw, but usually your orientation, you like to face the forward. Now, why you want to turn 90 degrees? Then you'll have orientation issue. You can draw whichever way you want. But logically, if you see on a ship, if you look forward, right? So it is easier for you to visualize things, right?
Yes, sir.
Right? Tomorrow you want to say, I want to have forward to the left and to the right, I want to have aft. It's okay. I have nothing against it. That's why I had written forward and aft so that everybody's orientation is same, right? Okay,
Yes,
guys. Okay, guys. Now, next, what do we have to find out? We'll have to find its geometric center, yes or no? Correct? Correct, guys?
Yes, sir.
Correct, sir.
Let us say the geometric center is here. Let's say, I'm just hypothetically saying. Then what do we have to do next? Once the G is found, then what do we have to do next? Tell me, to find
So,
FSM.
so this is the fore and aft.
We have to draw fore and aft
This will be
axis.
fore and aft.
Okay. So draw a fore and aft axis through G. Mark it XX the way we have been marking. So do you agree with me? Okay, which is the axis of interest in this case now for I of free surface?
So the one which is getting terminated, the one where all the ordinates are getting terminated.
You're not heard my question only.
Interline.
Which is the axis of interest?
fore and aft.
In the diagram, yeah,
Longitudinal bulkhead. Longitudinal bulkhead.
you want moment of inertia about longitudinal bulkhead. Is that your axis of interest?
Vertical axis. Vertical axis.
Which one?
XX.
XX.
X, sir, XX.
You for moment. What is I? I is about which axis?
2GC.
I is about.
Speak in context of the diagram, man. Please speak in context of the diagram. Yeah, don't go all over the bloody place.
Axis 2GC.
I is with respect to which axis?
XX.
Fore and aft axis to G.
Arey yara, please. Are you not listening? I'm saying talk in context of the diagram. Now, why you want to keep speaking lengthy phrases now when the diagram is in front of you? Which is the axis of interest?
XX.
XX. So then, when you were telling me every time in COP liquid level was the axis of interest, then why are you talking of 20 different axes when you know that you have to get inertia about XX? Yes or no? Correct?
Yes, sir.
Yes, sir.
Am I clear? What do I mean by axis of interest? Clear, guys?
Yes.
Okay. Now, is it a case of horizontal ordinates then with XX and ordinates orientation? Is it horizontal ordinate or vertical ordinate?
Sir,
Vertical.
sir.
Vertical ordinate, okay. And for vertical ordinates, we must have them terminating at one axis. So that means they don't all terminate at XX. So therefore, we will have to work about first this axis. This is because we have to work around out of compulsion, not out of choice. Had I been able to work about XX directly, I would have been happy. So that means I'll have to work about ZZ or YY, whatever I call first, and then get about XX. Am I right, guys? Have you understood why it's being done so?
Yes.
Correct? Anna? And what will be the tabular? Make the table for vertical ordinates about ZZ. First write the column headers, then I'll write. Make the Simpson's rule table for moment of inertia about ZZ for this particular case which is on display. I don't want to give any hint. I'll make and then you can compare. Guys, have you done this or yes or no? Or you made something else or made a blunder? Tell me.
Same, sir.
Have you written the axis in the subscript? ZZ? Have you written? Yes or
Yes,
no?
sir. I have calculated this ordinates also. I mean,
Okay, okay. I
inertia.
will. Okay. Never mind. We'll take. Okay. Now, next will be you will give me summation here in vertical ordinates. You will give me summation here. Please complete the table. Which rule to apply? I don't want to comment on that. Give me the summation values.
So product of area 55.
It's 445. I'll write no problem. I have the values. You guys can tell me. And if I'm wrong, then you can correct me. Are these the values?
4135.
Yeah.
Yes, sir. Yes, sir.
Everybody to complete this and tell me when you are done so that we can proceed further.
सर तो आई जेड जेड मेरा 4225 आ रहा समेशन सर.
गलती होगा, गलत होगा बेटा, तुम्हारा चेक करो. This is the correct value. You made a mistake somewhere. Which rule are you applying?
Sir, rule 2, sir.
Yeah, so these values are correct. Just check. You must have made a mistake
Correct,
somewhere.
sir. Correct. 4135 is the same. Sir.
Yeah. You must have made a mistake. That's what I'm telling you. Is there someone who's still solving? Please let me know. I'll wait for you.
Yes, sir. One moment, sir.
Okay, please do it and let me know once done.
Okay, sir. Done.
Okay, now fill up these SOP area, SOP moment about ZZ, and SOP inertia about ZZ. Please, I don't want to give any hints now. If you make mistakes, you'll realize by yourself. If anybody is having any doubts, you can ask me. I don't want to even speak what I'm doing because I presume you are getting what I'm doing, right?
Sir, I'm getting this some different values. 68, 534, 477.
You must have made a mistake somewhere, beta. What can I do about it? Check your calculations.
Okay, sir. I'm using sense and rule 1.
So how can you use rule 1 in 4 ordinates? Tell me, my friend. In 4 ordinates, can you use rule 1?
Yes, sir. There is the mistake. I cannot.
Okay.
Done, sir.
Okay. Does everybody understand? I don't even want to say what I have done in green. Does everybody understand what has been done or any doubts? Please speak up if there are any doubts.
No doubt, sir.
Very good. So now. Uh, guys, anybody wants to stop me or shall I just continue? Okay.
Continue, sir.
Continue.
Okay, guys. Now, FSM will be equal to I about XX of what? Free surface multiplied by DI. Now, I about XX we need. Okay. Guys, we are going to get about Z. Okay, so this is what my problem statement now is. So what do I need to do? I will have to use theorem of parallel axis, for which I will need this distance D also. Yes or no? What is common interval? Common interval is given as 4 meters in the question. So can you please calculate quickly the area of the free surface? How much is the... I've written A, but I'm talking to myself and saying it's area of the free surface. How much is the area of the free surface?
82.5.
82.5.
82.5.
Very,
82.5.
very good, guys. And can you calculate D, the distance between ZZ and XX? I don't want to give any hints now.
4.045.
4.045 is what I am getting, beta. Unless I have made a mistake.
Correct, 4.045. Yes, sir.
Correct, sir.
4.045.
Okay, very good. Guys, everybody, all 50, 60 of you are aligned on this. It's giving me a lot of pleasure to actually see that when people are understanding, it's actually giving a lot of happiness, guys. So I hope A and D is okay with everybody.
Yes.
Guys.
Yes, sir.
Now, I don't know. Sorry, say again. Understood better?
So only I had a doubt. How did you come at
4.045.
You can't find out D. Distance of the geometric center from Z, you can't find out better. We did it yesterday also. We did in COP also. In COP we did, yes or no? We were finding the DLL.
Yes, sir. Found out. Thank you.
In COP you were finding DLL, no beta? It's the repeat of the same thing. Okay, done. It's moment about ZZ divided by the area. That is what will give you the D from ZZ. Can you mute yourself? There's an echo from somebody's system. Okay, thanks. Okay, now guys. I'll not give you any hint. I need IXX. Can you tell me what will be the expression for by theorem of parallel axis for IXX? Be careful. I know
IZZ minus
IZZ
A into
IXX plus
DZ square.
square.
You write whatever you want to write in rough. Give me the expression for IXX. IXX is equal to what?
Sir,
IZZ minus
IZZ
Very good.
minus
Why,
A
very
into
good.
DZ square.
IZZ minus A into D square. Correct, guys? This is minus out here, right? Correct? You write the theorem of parallel axis between XX and ZZ in your rough and see what are you getting IXX equal to. That is what has to come here. Correct, guys?
Yes, sir.
So now IXX would be equal to IZZ will be equal to, we have used rule 2. So 3 by 8 the coefficient, 4 the common interval, and 1378.333 is the SOP inertia. The units of this I will be meter raised to power 4 because it is the second moment of area, moment of inertia, guys. And this value comes to 717.632 meter raised to power 4. Can you calculate and confirm A, the value? 2, have you understood the process until this point?
Yes, sir. Answer is correct. 717.6.
Yeah, but have you understood what is done? That is also to be confirmed, beta.
Yes, sir. Yes, sir.
So I'm happy that most of the class said IZZ minus AD square. And this gives us FSM, guys. FSM will be equal to 717.632 into the density of the liquid and it will be so many ton meter. The answer is on the screen. It is 724.809. 809, not 8089, 80. See how simple the question is if it is systematically tackled. There is no complication. You need to just keep your cool and
Excuse me, sir.
yeah.
Sir, IXX value you have put like equal to 3 by 8 into 4 into 1378.
Yeah.
So that one, sir, IZZ, no?
Oh, sorry. Sorry. Oh, sorry.
Minus
My
8 is
mistake. Okay, my mistake. My mistake. Achha. But this answer must be correct, right?
No, that is coming around 717.330, sir.
Yeah. Okay.
Right?
Six. No. Yeah. Okay. I forgot to minus that. Okay. My mistake. You're right. You're sorry. My mistake. Minus area. Area you got 82.5 beta. Sorry. Into D square. D you got was 4.045. 4.045 square. Answer will be 717 only. 717.632.
Yes, sir.
I'd written the answer correctly. Only thing is I missed out on this expression which you have corrected me. Thank you. IXX will be equal to IZZ. So first is IZZ I'm writing. I'm writing it all over again here. Into 4 into 1378.333 minus area 82.5 into D square 4045 square, and this is what comes to, as per my calculation, which is subject to correction if there is any mistake. This is the IXX calculation. You can ignore what was done here. Okay, you can ignore this one. Is that clear now?
Yes, sir.
So I give you 10-15 seconds for everybody to close it out, have a re-look at the solution, and raise their concerns if any.
So just wanted to ask, like, in this kind of questions, you can directly write IXX is equal to IZZ minus A into D square.
Yeah, you can write, or you can write about ZZ, and that's up to you. You can write straight also. Nothing wrong. Nothing wrong. But if you want to write that additional thing, IXX, IZZ first, and then write the next step, this one, that is also okay. That's your choice. Both are okay. Okay. Right, beta? So, okay, what else? Yeah, please do it. Complete, no problem.
Finished.
Finished? Everybody is finished?
Yes.
Anybody wants me to wait more? Has everybody understood, guys? Okay, good. We go to the next question then. Read this one. A box-shaped vessel, 40 meter long, 10 meter wide, is floating at a draft of 3 meters in sea water. The kg and FSC of the vessel are given. It has an empty cuboidal DB tank. So the shape of the tank is stated. 10 meter long, 5 meter wide, and 2 meter high. Find the GM of the vessel after the DB is ballasted to a sounding of 1 meter. After the DB is ballasted to a sounding of 1 meter. Okay. And you see, I'll take you through this question and you will realize once you do it that you knew everything. But if you were to do it on your own, for sure you'll miss out some part if I tell you to do now. But whatever I'll be doing is all that you know. There is nothing new that is going to come. Okay. Now, first is, let me make the vessel. It's 40 meters, 10 meters, 3-meter draft, and so this is the initial draft of the vessel, and our displacement is not a kg is given. Kg initial is given as 3.5 meters, guys, in the question. Our FSC initial is given as 0.080 meters. And then, of course, the tank is there. Wherever it may be a longer line, doesn't matter. Okay. I'm sure with this, since she is floating in sea water, we know the dimensions of the box-shaped vessel, we can get the initial displacement. Can you get the initial displacement and give me the value? If somebody is not getting it, then only I'll explain. Guys, can you get the initial displacement? Write down the step and get it and tell me the value.
1230.
Very good. 1230. Is everybody getting 1230? Yes or no? Or I change the question. Is there anybody in the class who doesn't know how to get 1230? Please speak up.
1230, sir.
Yeah, anybody in the class who is not able to get 1230 or doesn't know how to get the initial displacement for this particular case. If everybody knows, then I'll not take everybody's time here, then it is 1230. Okay, very good. What is the kg initial of the ship? Kg initial is given as 3.5 meters. Guys, can you find out the weight of the ballast that is taken?
51.25.
51.25 is he saying. Anybody who doesn't know how to get the weight of the water ballast taken, question is on display. This is simple concept of
Can you
volume.
explain about the displacement also and its weight?
Now I'll not explain you displacement, beta. I asked 3 times. Are you being fair to the class? Because you thought either I'll explain myself or somebody else would ask. Are you being fair to the class? Tell me.
Yes.
You're being fair to the class. When I asked you at least 4 times before proceeding further, you did not open your mouth.
Yes, sir.
Sorry?
I already asked you, sir, to explain about that.
When did you ask me? After I went to small w, right?
Sir, one question. Sir?
So one second here. Let me finish with one person first.
Okay.
Did you ask me when I was in displacement initial, beta? That's not the way I teach here, please. I give everybody enough opportunity to ask doubts.
Sir, one question.
Let him speak first, Nayar. Your question I'll take. Wait for a while. I'm talking to the person who was asking about initial displacement. You cannot just fool around with the class like this, man. That's not the way I expect my class to behave, honestly. Otherwise, effectiveness of the class will go for a toss. Then I'll be only in appeasement policy to just get people for tutorials, nothing else, and there'll be no efficacy then. You can't get who asked about initial displacement? Can you identify yourself?
Yes, sir. Myself, Saurabh.
Saurabh, you can't make out how to get the initial displacement by law of flotation? What is the underwater volume of the ship? Tell me, beta. Look at the diagram. Tell me what is the underwater volume.
Sir.
Ajay? How will I get underwater volume? What do I add? What do I multiply? What do I divide? Saurabh, speak fast.
Yes, sir. It's 400.
No. What do I add? Divide? You tell the. Don't give me the value. Tell me what to add or divide or multiply. What numbers to do?
40 into 10 and 40 into 3 into 10,
40,
sir.
40 into 10 into 3 is underwater volume. We are sure about it. And if you have the underwater volume, how do you get the displacement of the ship then?
Multiply with
Sorry?
the volume multiplied by the RD, sir.
So then do that and tell me how much is it coming on your calculator? How much is it coming on the calculator? Calculate fast, Saurabh. Please give me the value. Saurabh, how much is it coming? Calculator has to multiply, man.
Yes, sir. I'm. 96.
96.
Thank you so much.
40 into 10 becomes 400 and you are telling me 96.
अरे RD 1.025 मल्टीप्लाइंग विद 0.06 के साथ कर रहा है सर ये तभी 96 आएगा इसका
क्या चीज
सर ये जो अपना 0.080 दिया है ना RD की जगह उससे मल्टीप्लाई कर रहा है तो 96 आता है वही कर रहा है वो 1.025 से
बेटा 90 नहीं वी आर टॉकिंग ऑफ इनिशियल डिस्प्लेसमेंट ऑफ द शिप वो 96 कैसे हो जाएगी यार
40 into 10 into 3 into 1.0.
हाउ कैन
डेंसिटी
1200
गलत है
अरे कितनी भी डेंसिटी गलत ले लो यार
नहीं उन्होंने क्या किया ना जो एफएससी दिया वो डेंसिटी ले ली उन्होंने तब गलत आ रहा उनका
भैया फिर तू ही पढ़ सकता है उसको जो तेरा दोस्त है क्या जो तू यू नो हिम इनसाइड आउट इज इट
नहीं मैंने देखा कि
वो सभी वैल्यू आती है अगर वो 0.080 ले रहा है वही मिस्टेक है
Saurabh, in which density is the ship floating? In the question?
1.025.
1.025. So then what is the answer coming? Guys, let me just tell you, if you don't ask the doubt when I'm at that particular point, I'm not going to go back and address. I'll not eat everybody's time like this. You need to be prompt in asking your doubts. I think that ground rule must be respected in the class. You just cannot have a laid back attitude and then expecting that either somebody and the things will happen. I'm sorry, yeah. This is I don't mind wasting another 10 minutes lecturing on it, but this is not the way to. Saurabh, this is the underwater volume. This is the seawater density. The vessel is floating in seawater. Question says 3 meters in seawater. What is the problem with
1230?
So what was the confusion? Tell me what was the confusion. Now let me also understand why were you getting stuck on it.
No, I was confused about the RD, sir. Now understood, sir.
Okay. Now tell me how much will be small w. Then calculate small w. If small w will be equal to the volume of the water ballast. It is taken in a tank which measures 10 by 5. So 10 into 5 and it's taken up to a sounding of 1 meter. Into sounding, this becomes the volume of the ballast multiplied by density of the seawater becomes 21.25. Correct, guys? Yes or no?
Yes, sir.
Okay.
Yes, sir.
Okay. What will be the kg of the water ballast? Okay. Somebody had to pour out some. Please ask.
Yes, it was me. Sir, is it important to show this second cuboidal DB tank in the diagram? If so, can you show?
No need. You can in the side elevation. I can show it wherever I want, but it will not serve any purpose.
Okay, so no need, right? That was my doubt.
No, not required. It can be anywhere along the length, anywhere along the breadth, doesn't matter, right?
Yeah, I mean just for clarity.
Oh, no, in this diagram it will not come. Okay. What is the kg of this water ballast, guys?
0.5.
0.5. Sounding, half of the sounding. Any questions? Okay. Saurabh, are you okay with 0.5, beta? Saurabh, are you okay with 0.5 kg of the water ballast, beta?
Yes, sir.
Okay, very good. Shabash. Saurabh, now find the final displacement and give me, after the ballast has been taken, how much will be the final displacement? फटाफट कैलकुलेटर हाथ में उठाओ.
Just a moment.
So,
No, sir. Sir, 125829.
1281 आ रहा है भाई. 58 कहाँ से हो गया? क्या तू ऐड कर रहा है मेरे भाई?
1281.25.
हाँ. What are you adding? क्या ऐड कर रहे हो बेटा? What are you adding? Forget about my firing. Now tell me what are you adding? Where are you lost, man? Tell me exactly.
Now, sir, I am multiplying with this new RD 1.023, sir. Then
Which
for
one?
5.
What were you finding? I asked you to get the final displacement. Yes or no? Correct?
Yes, sir. Yes, sir.
So how are you getting the final displacement? Where is the new RD? There is no new RD. Where is the new RD? I don't see any other RD in that question. अरे भाई 1230 टन इनिशियल डिस्प्लेसमेंट है, 51 टन उसमें बैलेंस लिया, तो व्हाट इज द फाइनल डिस्प्लेसमेंट बेटा?
बोल ले मेरे भाई.
अबे दोनों को जोड़ दे भाई, दोनों को जोड़ दे यार.
अरे this is not going to solve his problem यार, please. Let's have patience. This is not going to solve his problem. That I can also tell you that put a plus sign here. Saurabh, where have you gone बेटा? क्या हुआ? Saurabh, what will be the final displacement? You can't add these two weights, is it?
Yes, sir. Yes, sir. Already 1281.25, sir. I got it.
So then what was the confusion? Where are you going all over the place, man? Okay, now, question says find the GM. Beta, how do you find the GM? What is the formula for GM? Obviously, it is GMT, right? What is the formula for GM? How do you get GM?
Km minus kg.
That's all?
Minus kg minus FSC.
Very good. Does everybody agree with this? Okay,
yes.
Fantastic. How do we get Km? We yesterday touched upon this part when we were doing BMT, BML. What is Km equal to?
KB plus
PM.
BM minus kg minus FSC. Correct, guys? So if I have to get the GM, which is required by the question, I need to get the ship's kg in the final condition. I need to get the ship's BM in the final condition. I need to get the ship's kg in the final condition. And I need to get the ship's FSC in the final condition. Yes or no?
Yes, sir.
Correct?
Yes, sir.
Okay. It is a box-shaped vessel. What will be KB equal to in terms of parameters? Half of draft. So that means first I have to get the draft final. Now, how do I get draft final? It's a box-shaped vessel. What is it displacing? It's displacing 1281.25 tons. If I divide it by 1.025, what does it become, beta? It becomes the underwater volume in the final condition.
जी sir.
And if I divide by length and breadth, it will become the final draft. Yes or no?
Yes.
See,
Yes, sir.
in phase two, you will just write like this and finish it off. You will not explain, because if you go on explaining, the question will never come to an end. So this DF comes to 3.125. Anyway, in the class, anybody has any doubts, you can ask me. Is everybody okay with how we got the draft final? Final
Yes.
displacement was divided by the RD of the water in which ship was floating. That gave us the underwater volume. And if the final draft is DF, the underwater volume will be length into breadth into draft final into the density of seawater. It is equal to 1281.25. You keep DF on one side, take everything else on the other side. So 1.025 will come here, length will come here, breadth will come here, and this is what we have done here straight away. And we got this draft. So what does this give us, guys? This gives us KB, and KB will be 3.125 divided by 2. So how much does the KB become? 1.563 meters. So this is KB. All okay up to KB? Any questions up to KB, guys?
No, sir.
Okay, very good. Now we come to, next we need is BN. Look at the tank and tell me, guys, what will be the shape of the free surface? Only the shape. Name the shape right now. What will be the shape of the free surface in the tank?
Rectangle.
Okay. And okay, I'm drawing the rectangle. Now tell me what will be the dimensions of this rectangle of the free surface? What are
40 into 10.
40 into 10. Are you sure? Look, read the question
Sir,
again.
10 into 5. 10 into 5.
10 into 5.
This is the shape of the free. Gentlemen, I have not drawn the water plane. I have drawn the free surface inside the cuboidal tank. So the dimensions of the free surface will be 10 into 5. Yes or no?
जी sir.
Any questions on the shape of the free surface and the dimensions?
No.
Next, I have to identify the geometric center of this free surface. That will be here. Then I have to draw a 4.5 axis through it. This is this. I mark this axis as XX, as we have been always doing in such cases. Guys, what will be, okay, this is free, okay. My mistake, I'm sorry. So we are now calculating the FSC part. Okay, never mind. It was my mistake, I'm sorry for it. Never mind, let's continue. What will be IXX, guys? 10 into 5 cube upon 12. Okay. Now, this tank was earlier empty. So was it contributing to the initial FSC? This tank was initially empty.
No,
He
sir.
says empty.
No, sir.
So that means a new free surface has been created, correct?
Yes, sir.
Yes, sir.
Okay. So what is this IXX coming to?
125.
125, okay. So what will be the FSM caused? Let me first deal with FSC.
104.1.
कितना आ रहा है?
104.167.
104.167. 167. Okay, fine. What will be the FSM caused, beta? But I don't know.
Multiply by density.
Yeah, multiply by density. It is coming 106.771 ton meters.
Yes, sir.
Okay, now let's take a pause here. Guys, I have calculated how much is the FSM caused because of part filling up of our empty tank. Is everybody okay with the FSM that is caused? Saurabh, especially you, beta. If you're not clear, let me know. What have we done? So I was wanting BM, but I started on with free surface. So now I'm calculating FSC, final FSC. Okay. So I'm calculating this part first. Never mind. So what have we done? The tank was initially empty. Then we partly filled up. The tank has a free surface. Free surface will be rectangle. Why? Because it's a cuboidal tank. Dimensions of the free surface will be 10 into 5. Geometric center of the free surface will be at G. We drew a 4.5 axis. IXX is a standard axis, so 10 5 cubed by 12 and multiplied by density of the tank content. This gives you FSM caused. Is that clear, guys? Yes,
Yes,
or no?
sir.
Okay.
Yes, sir.
What,
Yes, sir.
okay. What was the FSM initially when the ship was there in the initial condition?
0.080.
Was that FSM?
98.4.
FSC sir multiplied by displacement.
Yes. Okay, so initial FSM was your FSC was 0.080 and displacement was 1230, which comes to 98.4 ton meter. Correct, guys?
Yes, sir.
This will give us final FSM. Final FSM, you add the two, it becomes 205.171. Correct? Everybody is okay up to FSM final?
Yes, sir.
Okay. So now, what will be the final FSC?
Final FSM divided by final W.
Yes, very good. So final FSC, I'm writing in blue here, will be final FSM, that is 205.17. 25 into 160. Is that
Yes, sir.
Yes, sir.
so this is 0.160 meter. I have already calculated this FSC now. Guys, up to FSC, everybody is okay?
Yes, sir.
Okay. So this we have applied what we learned today. Actually, I wanted to calculate BM first. I wanted to calculate in this order as they were listed, but never mind. I went this way, it's okay. Guys, another 10 seconds for everybody to review how we got the final FSC. If anybody has any questions.
Sir, if we can add, sir, in initial FSC plus.
No, you cannot listen. You cannot add FSC, initial FSC to final FSC. Why? Because FSC depends on displacement also. Okay, so the initial FSM had a different FSC when displacement was less. The FSC was more, but with the same FSM, if the displacement increases, the FSC will decrease. Correct? So you can't add.
Correct.
You can't add initial FSC to the FSC caused. Okay, beta.
Okay, understood, sir. So we can get the final FSM.
You have to get final FSM. Let me just write it here, beta. FSC will always be equal to FSM upon displacement. If this is initial, this will also be initial, this will also be initial. If this is final, this will be final and this will be final. Is that clear, beta?
Understood, sir. Thank you, sir.
Okay. So please don't make that mistake. You cannot add FSCs. Okay. Okay. Any more questions on FSM? This FSC. Final FSC, beta. Okay. Now we come to calculation of BM. Recall yesterday's class. For BM, which is the area of interest? Name the area of interest.
Water plane.
Water plane. It's a box-shaped vessel. What will be the shape of the water plane now? Now I am going to draw the water plane, as you tell me. What will be the shape of the water plane? Rectangle. What will be the dimensions of the rectangle?
14 to 10.
14 to 10.
14 to 10. Where will be the geometric center? Here. And that is called a center of flotation, right? Correct, beta?
Yes, sir.
Now when I draw yeah, tell me.
Sorry to ask a very stupid doubt. So why are we taking 40 into 10 for water plane of the area of the ship, right?
Water plane is not of the tank. Water plane is of the ship. Tank had the free surface. So there are two distinct terms we are using.
Okay, so can I reason out why for water plane we are taking not the tank?
What is the formula for BM? I'm sorry, water plane of the tank. What do you mean? Say again.
No,
What
no,
did
no,
you say?
no, that was the first doubt I erupted.
So that is clear. For the tank, you have the free surface. Water plane is for the ship.
Yes, yes, yes.
Okay. Now, what is the other question?
No, no, that was all. That was all.
Okay. So that will be 40/10 for BM. Yes or no? Correct,
Yes,
beta.
sir.
And what is the formula for BM? You draw up 4.5 axis through center of flotation. Correct. Geometric center of the water plane will be center of flotation. Correct, guys?
Yes, sir.
Yes, sir.
Yes, sir.
So this axis will be center line. Correct?
Correct, sir.
Yes, sir.
So the BM of the vessel, how much will be the BM? BMT. It will be I of the water plane about the center line. This particular diagram, guys. This diagram. This diagram. Yesterday we did for a box-shaped vessel. It is B square upon 12D. Yes or no?
Yes, sir.
So BM in the final condition will be equal to B. You can find by I upon this also, or you can cut short. It's your choice. Since you know the formula for rectangle box-shaped vessel, you can use cut short also. Okay. So this will be, yesterday we arrived at this formula B square upon 12D. Yes or no?
Yes, sir.
Yes, sir.
Or you can say I upon V, whatever way they'll cancel and come to same thing. So if you're talking of BM final, then this draft has to be final. Yes or no? Yes or no, guys?
सर इसमें हमेशा हम लोग BMT ही लेंगे, BML नहीं लेंगे.
बेटा अगर लॉन्गिट्यूडनल AM, लॉन्गिट्यूडनल GM, लॉन्गिट्यूडनल BM की बात होगी तो आपको L लगाना पड़ेगा उसके बाद. और ट्रांसवर्स के लिए आप T लगाओ या मत लगाओ. इफ यू डोंट पुट एनीथिंग बाय डिफॉल्ट इट बिकम्स ट्रांसवर्स. ओके.
Okay, sir. Thank you.
Okay, guys. So, guys, can I cut short on this formula, or do you want me to take that I upon V thing? I think we should.
No, this is okay, sir. This is okay.
Yes, such a lengthy question. We should cut short. Always on steps, right? We cannot keep writing story for every step. Okay. Yeah. You can say for a box-shaped vessel. For a box-shaped vessel, BMT is equal to B square upon 12D. You can just put that, no? So in this case, breadth is 10 of the vessel, 10 into 10 upon 12, and final draft 3.125, guys. Be careful, don't use the old draft.
2.667.
Yeah, 2.667. So don't use the old draft. That is the mistake sometimes people make. I'm warning you upfront. So now we have got BM 2.667 meters here. The BM has also come now. Let me know if there is any doubt up to this point. Okay, what is left now? KG.
KG final, sir.
KG final, yes. So KG final, you know the initial displacement, you know the initial KG. You see? Correct. So KG final, let me do it here for every, and you do like this the way I'm doing. See, don't unnecessarily write too many steps. Talk to yourself like this. KG final will be initial vertical moment, which is initial displacement into initial KG. I'm talking to myself and I'm just writing. I have loaded the weight plus the vertical moment of the weight loaded, 51.25 multiplied by the kg of 0.5 meter for that ballast, divided by the final displacement 1281.25, and this kg, firstly everybody to evaluate this working, and then this comes to 3.380 meters.
3.380, sir.
Yeah.
Yes,
Guys,
sir, same, sir.
Yeah, everybody's okay with this kg that I have written. I have spoken to it. I have explained also. But if anybody has any doubts, let me know. So now we have everything here. 3.380 minus FSC. When we do this, we get GM.
0.69.
0.690.
0.69.
Yeah, 690 meters is the answer. So in this one question, you have used the concept of the law of flotation. Okay, you use the law of flotation. You can use the concept of kg. You use the concept of bn. You use the concept of FSC, and you use the concept of calculating I of the free surface. Everything has been revised through this question. Many concepts have been revised in this question. If anybody has now, this is, guys, when I sometimes get not irritated, when I'm little tough on you, believe me, it's only with the intent that you guys pull yourself up. Saurabh may not be the only one having problems. Please do not hesitate from asking your questions. My only request time and again has been, let the doubt come while we are at that point. That's all. Because going back derails derails the process and eats into everybody's time. That's all my request is. So law of flotation, kg, FSC, BM calculation, I of the free surface calculation, all have been put in one question. Is that clear to everybody now?
Yes, sir.
Very good.
GM sir 0.681 है sir.
बेटा कहीं गलती होगा तुम्हारा. -690 and somebody else has also validated it.
Yes,
You
yes.
see which value is not matching. KB 1.563, BM
Yes, sir.
2.667, KG 3.380, and FSC
Yes.
0.16.
Maybe sir मैंने calculator में गलत
Yeah,
put कर
no, somewhere you have put wrong values. It will give. Thank you. So, how did you find this question useful, beta, for also revisiting many basic concepts?
Yes, sir.
Nice questions.
Yeah. So, questions like this they are coming in the exam. This is not from the
Sir,
exam.
ये KB, sir, I'm not getting where KB came from. Sir.
KB came from half the final draft. For a box-shaped vessel, the KB is half the draft. Do you agree with that? Tell me, beta.
Yes, sir. Yes,
For
sir.
a box-shaped vessel, the KB is half the draft. Yes or no? Yes or no, beta?
Yes, sir. Yes, sir.
Okay. So what was the final draft? This 3.125 meter circled here is the final draft, no? This one here. Here. Where I'm taking the red one now. Here.
Yes, sir. 3.125. We got it. Yes, sir.
So it was half of it. Final KB will be half of final draft, no, beta? Final KB will be half of final draft, right?
Okay, sir. Yes, sir. Thank you.
So you divide that by 2, you'll get KB. Anything else? Okay, we go to the next one then.
Possible 2 minutes break.
Yeah, please. Okay, what's the time now? 44. Can we take 6 minutes break? 10:50 can we start?
Okay, sir.
Okay.
Yes, thank
In
you.
the meantime, I'm putting up the next question. Anybody who wants to use this time, it's up to you. Okay. Confuse you. ये MMD का question है. So this will be doing. Then we have this one question. Then this is about 3 more questions are left, and then we close this topic. Take a break. No mind.
5 minutes break.
Kasama pala, tipo, susunan ko pala sila. अच्छा हाँ तो नहीं मतलब 3-4 घंटा गैप रखा तूने तो भैया पे कोकोरा बहुत gotcha अच्छा शुरू कर लो ना ठीक है अरे शुरू में करबो तो तेरी दिक्कत हो दर्द होई लेकिन आराम हो जाई हफ्ता भर में फिर ठीक हो जाई एक्सरसाइज कहाँ से शुरू के लिए वो कैसा अरे तो कैसा शुरू के लिए वो कहाँ से देख तो देख के कहाँ से कर अच्छा हमसे अरे हमसे क्या बता चलो ठीक होता है तो मौसी को सिखा दे तू अरे मौसी को सिखा दे तू तो तेरी मौसी को सिखा दे तू वहाँ को बदल के काम करे एक बार आउंटा तो तार तब तरी उतना नहीं के पाल मौसी के ढेर पड़ा होगा हेलो भागम भाग से नहीं वजन कम होला हाँ डॉक्टर कहलस मौसी कहली कि हम पहाड़ वार करते कहते हैं कि चलने से भी वजन कम नहीं होता आपको एक्सरसाइज और योगा करना पड़ेगा तो वो कह देते मौसी को सिखा दे तू एक्सरसाइज और विक्की वाला ना तो कोई नहीं यार विक्की तक कठिन वाला करेगा धीरे धीरे करेंगे तो वही तो तेरे तेरे दुखाई जितना लेकिन दवा तो जितना नहीं दवा अच्छा ये तो सब लोग ऐसे उठ जाएंगे लेकिन सब लोग चले जाएंगे है ना सब लोग ये कहाँ भाग के जाएंगे तो जा रहे हैं देख रहे विकी को 10-15 दिन चल जाएगा तो नहीं फिर नहीं कर जाएंगे तो अब विकी ए सुनो बताइए एशिया सोचो तभी तारीख वाला कौन बता दी हाँ अरे बहुत पसंद विकी कह रहा बहुत ज्यादा गर्मी पड़ रहा है हाँ तभी ना कह रहा बहुत ज्यादा गर्मी है तभी तो कह रहा है कैसे लगा नहीं अरे हम भी कराते नहीं जाते हमने भी फोन लगा कर काट हाँ जरूरत पड़ी तो पूरा वक्त नहीं था हाँ मतलब आगे के बाद वो 2 से 3 दिन तो पूरा चला के तो मैं ना पड़ गया तो पूरा नहीं लगे मुझे तो पूरा तब वो काम करी थैंक यू बात काम का तो वो सोचना लगा करी तो लोगों को लगा या नहीं ऐसी या ना नहीं हम अपनी वाला रूम लगा लेता नहीं तो लोग जो को हम सुतो तो रही हो अरे हम पहले एसी लगा कर बात करते हैं नाही तर व्यवस्थित करी अब चटाइया जो खाते हैं जो ऐसे लगवा दिया साइड में ऊपर क्या कर रहे हो हैं
Okay, guys, are we ready to go?
फिल्टर टाइप के
Ready, sir.
Okay, good.
Ready, sir.
Good. Here is the question. Some of you may have struggled with it when you attempted your exams earlier. Those of you might have been repeating the exam.
नहीं भाई होगा
So this is from MMD exams. I don't know which month it was there. Probably it was not clear to me in the photo that I would have got. So, but for sure it's from MMD exams. Okay. So the source is correct. Month probably was not clear, so I have not written anything yet. What's the time? Let me see. Is it 50 past? Start. Okay. Guys, a pontoon consists of two large cylinders floating in water of RD 1.025 with their axis of whose? The cylinder axis being perpendicular to the water line. And these two cylinders on top are joined by a wooden plank or a wooden deck. Something like we used to make raft of the ships. Only thing is, there we used to put these drums in the horizontal condition. Here is put them vertical. Diameter of each cylinder is 4 meters. That means radius of each cylinder is 2 meters. And the distance between the cylinder center to center is 5 meters. Pontoon is floating at an even keel draft of 4 meters and has a light kg. That means in the light condition, the pontoon floats at a draft of 4 meters and has a light kg. Kg of the pontoon is 3.6 meters. Seawater is then taken into each of the cylinders to a height of 2 meters and a load of 2 tons whose kg is 15 meters placed on deck 2 meters off the center line. Calculate the list produced. Okay. This will be again the list question will take you practically through everything that we've gone through the last question. Of course, the shapes will change, but concepts are not going to budge. So let me first make a diagram for this particular question. You have two pontoons, the two circular drums. One is like this here, and another is somewhere here like this. They both are circular in shape, cylindrical in shape. They are 2 meters of radius or 4 meters of diameter, whatever you want to say. And from center to center, the distance is 5 meters. That is what the question says. On top, they are connected by a wooden deck. See, many things get resolved when you make a proper diagram. So here is the deck, guys. So they are connected by this deck. Okay. Now, obviously, guys, which will be the fore and aft line of this pontoon? This will be the fore and aft line. Why? One side forward, other side is aft. Why? Because when you drag this pontoon, you will have lesser resistance to water in this condition when one cylinder is behind the other. Otherwise, when you pull it the way it is drawn, then it becomes a thwart ship. Correct? Because normally when you drag a pontoon, so its fore and aft direction will be determined either by the length if it is given, or it will be determined by the side on which the lesser resistance is offered. So do you agree why I have called this as fore and aft? Because tomorrow somebody may say, I want to treat it's fore and aft the other way. I want to treat fore and aft like this. You can do it, but A, it is against the normal shipboard experience. Secondly, this will complicate the question further. Question can still be solved, but the question will become more complicated for you. So we will take this as the fore and aft side. Am I clear, guys? Guys, am I clear?
Sir. Yes.
Okay. Now, This pontoon in the light condition is floating at a draft of 4 meters. This is the in the light condition, it is floating at a draft of, so draft initial is equal to 4 meters. And then we take ballast up to 2 meters. That's up later on we'll do. Okay. Now, and then then 2 tons of weight is placed off the center line. So if I want to draw it in the diagram, then this is my center line, guys. This is my center line of the pontoon. If this is the fore and aft side, this is the center line. Then 2 meters on each whichever side you want to take. It is kept on 2 tons of weight is kept here. And obviously, this will cause the vessel to list. List is what you need to find out. Is the question now clear before we start solving it? Or any doubts in the question, guys?
So just 1 minute, sir.
Yeah.
So they haven't mentioned which side, right? Placed or load of 2 meters.
Port starboard, it doesn't matter. So it is kept on one side. So it will list that side, which side it is kept, right?
So here we have kept on the starboard side. What I mean?
It doesn't make a difference. If you talk this as forward, this becomes starboard side. If you call this aft, this will become port side. This was only fore and aft direction I meant actually, right? So it could be kept either way, either side, right? For me, in the diagram on this side, these cylinders were coming, so showing on the other side was easier for me without messing up the diagram, right? So I put it on the other side, right? Correct, Peter?
Okay.
Okay. Guys, do you all agree with the diagram, with the text of the question? Because if there is a problem with, if there is a disconnect between the question and the diagram, let's first resolve that, because proper understanding of the question will help in solution. So I don't want to start solving the thing.
So can you mention in the diagram 2 meters from the center line also, so that
this distance is 2 meters, beta.
2 meters. Okay, yeah.
This distance is 2 meters, right? Clear?
Yeah, clear.
Okay. Can I proceed, guys? If the diagram is clear, okay, very good. Now, tell me who's going to tell me the first. Now I'm not going to do it as a question that you just do this. No. If this question comes to in the exam, how will you figure out? He says calculate list. You will spend 1 minute to figure out what all you need in the rough. What will you do? First, you will say, I need to calculate list. What is the formula for list? Formula for list is tan theta is equal to GG1 transverse upon GM, right? And what is GG1? It is small w into D upon capital W into GM. Does everybody agree with the formula for tan theta?
Yes, sir.
So that means I need to get all these. In this question, do you have small w? Tell me, read the question and tell me if you have.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Do you have small d? Yes or no?
Yes,
Yes.
This d is not draft. This is not draft.
Yes, sir.
2 meters, sir.
2 meters of the center line. Okay. The displacement will be, of course, the final displacement. Guys, we'll have to get, and we'll have to get the final G. And once we are able to get, this is not fluid, this is final in the final condition. And once we are able to get this GM, then we are good to solve the question, yes or no?
Yes, sir.
Yes.
Yes, sir.
Now you know this is how you figure out what all you need to calculate. So now, displacement will be what? Initial, the light displacement of the ship. And in the light displacement, the vessel is floating, the draft is floating at 4 meters even keel condition. Guys, would you like to help me in figuring out how do I get initial displacement?
Yes, sir.
Yeah.
Volume of cylinder into density.
Volume of one cylinder plus the volume of the second.
So volume of 2 cylinders into density.
Yeah, underwater, not the full volume. Underwater volume of the
underwater volume.
Yeah, correct. Multiplied by the density of the sea water. Correct, guys?
Correct, sir.
And what will be the volume of the cylinder underwater volume? It will be the area of the base multiplied by the draft height, right? Height of the underwater portion is equal to the draft 4 meter, right, guys? So you see, it is such a lengthy question. You cannot keep writing area of the base into height, volume of the cylinder. You cannot write all this, beta. What will you do? And if anybody is not understanding, please let me know. I'll parallelly open another sheet here. Yeah, I'll use this one then, or let me open one more, a blank sheet, on which if I have to explain something to you in more detail, I can go there. Okay. I'll open a parallel sheet here. Okay. So I can keep flipping between the two sheets without having to mess up this one to explain everything. Okay. Now, what will I do? I'll write like this. I'm talking to myself. Pi r square. So what do I do? 22 by 7 into r is 2 square. This becomes area of the base of one cylinder multiplied by the height, that is 4 meters draft. This becomes volume of one cylinder multiplied by 2 becomes volume of both the cylinders multiplied by 1.025 becomes the light displacement. I have spoken to myself, I was talking to myself so that I don't miss out anything. And I end up getting the light displacement as 103.086 tons. Value is not the issue. Calculator will give you the values. If anybody wants more clarity on how we got initial displacement, please let me know. Anybody in the class, if has a problem with the initial displacement, let me know. All good about it, guys?
Yes, sir.
बेटा किसी को भी क्लियर नहीं है तो दिस इज द सिलेंडर, वन सिलेंडर. Its water line is up to this place. This is the underwater volume of this cylinder. Draft is 4 meters. Volume of this cylinder will be the area of the base. This area, which will be pi r square into height is 4 meters. This becomes the volume into 2 for two cylinders multiplied by density of seawater is the displacement of this particular raft in the light condition. Yes or no, guys? Correct, beta?
Yes, sir.
Right.
Okay, very good. Saurabh, are you aligned, beta? Saurabh, are you aligned? अबे क्लास में है तू, नहीं है, गायब हो गया. He's not there. Okay, never mind. Okay, then he says the cylinder, you take ballast in the cylinders up to a height of 2 meters each. That means I take ballast this one and I ballast this one. And what is the sounding? Sounding is 2 meters. Does everybody agree with what I marked in the diagram?
Yes.
Sir, repeat again, sir, please.
Question says, then you take seawater in each cylinder to a height of 2 meters. What does it mean?
Okay.
Correct? Okay, beta?
Okay.
Okay, guys? Now, can you calculate the weight small w, I can call it as W1, that is the weight of the ballast taken. Can you calculate W1? Again, I will not write lengthy story.
51.537.
It will be the volume of the water ballast up to 2 meters multiplied by density. In one cylinder, how much is the water ballast? Area of the base, 22 by 7. R square, 2 square. Into what is the sounding? 2 meters. This is the volume of water ballast in one particular cylinder. We have two such cylinders into 2. The density of the water is 1.025, and this gives us the amount of water ballast that you have taken, which comes to
51.543.
51.543 tons.
Just half
Any
of it.
questions on W1 calculation, guys? I can go on the other sheet and explain in more details if anybody has doubt.
It's okay, sir.
Okay. Anybody, guys, on W1? If no doubts, fantastic.
No, sir.
Very good. Guys, what is the light ship kg given to us in the question? KGI? 3.5 meters.
3.6.
3.6.
3.6.
Okay, 3.6 meters. Guys, can you tell me what will be the kg of this water ballast, kg1?
60 meters.
kg1 of the water ballast.
1 meter.
1 meter.
1 meter, beta. Half the sounding, na beta? Yes or no?
Yes, sir.
Yes, sir. Yes.
Pakka?
Yes,
Okay.
Yes, sir.
हाँ जी sir.
Okay, very good. Then what is the weight on deck? Deck weight.
2
W,
tons.
2 tons. What is the kg of this weight?
15 meter.
15 meter given in the question, beta. 15 meter and 2 tons. Now, with this information, we are good to get the final displacement. This implies final displacement will be what? Light displacement of 103.086 plus the ballast 51.543 plus the weight on deck 2 tons, and this gives me a final displacement of 156.629, correct?
Yes, sir.
Yes, sir, correct.
So now we have got the third thing also here. I can go back into blue or I can write red only. Final displacement is 156.629. Now only fight is GM. Correct, beta? To get the list now, what is missing is GM only.
Yes, sir.
Any questions up to this? So see how we worked. We started with the formula for this list. We started figuring out what we need. We tried putting things together, and one by one, we have the W now, we have the D, we have the final displacement. Only thing missing is GM now. Correct, guys? You cannot keep giving additional information. You see, these steps when I'm writing, you can actually finish these in 3, 4 lines, 5 lines. Otherwise, you'll get lost in the working. You are not, but it is an imperative that you keep talking to yourself, because if you don't talk to yourself, you'll be lost again. Okay. We have just in the previous question seen that GM is equal to KB plus BM, which gives KM minus KG minus FSC. Yes or no, guys?
Yes, sir.
Yes, sir.
So we have to get all this damn thing now. Now, in this case, first look at the diagram. Look at the diagram. Tell me, what will be the relationship between draft and KB? Is there going to be any relationship? Yes or no, and why?
It will be half of the final draft.
It will be half of the final draft. Anybody in the class who feels it should not be, then I'll explain. If everybody is aligned, then it's okay. Tell me, guys.
Sir, I just want to ask if the weight is placed either side because it's not on center line. So will the draft on one side will be not more than the draft on the other side?
Beta, when we do stability calculations, we do it for even keel upright conditions. Even keel and upright conditions. Okay.
Okay.
This GM will be for upright even keel. Okay. That is why it's called GM initial, right? This is actually GM initial, if you remember, right? Initial GM is for upright condition, right?
Yes.
Any more questions, guys? So, okay, that means if I get the draft final, will everybody accept KB to be D by 2?
Yes, sir.
Okay. Now, I know the final displacement. Now, see, draft final will be equal to, again, I'm talking to myself. We cannot keep writing too much. 156.629. When I divide by 1.025, that gives underwater volume. And then I divide by the area of the base of this particular underwater volume. That is the area of the 2 cylinders. And area of 1 cylinder will be 22 by 7. Don't use 3.14, use 22 by 7. R square, 2 square. It is for 1 cylinder, and into 2 for 2 cylinders. Has everybody understood what I have written in this?
Yes, sir.
And this will give you the draft in the final condition. And this draft, unless I have made any mistakes, subject to, of course, Section
078.
Let me see. Well, it is 6.078 meters, right, guys?
Yes, sir.
Yes, sir.
Okay. Any questions up to draft? So if there is no question up to draft, then KB will be DF by 2, and this KB shall be then equal to 3.039, correct?
Yes, sir.
So we have got the KB 3.039. Guys, anything up to KB? Okay.
No, sir.
Okay. Now I'll go on the other sheet and come back here. This is
So
our
now can we after this go to BM then, like in the order?
we are going to BM only. Last time by mistake I went to FSC. We'll go to BM only. Don't worry. This was the deck out there. Here it is on the cylinders. And here is the final water line. This is the final water line, okay, after the weights are put on board. Tell me what will be the shape of the water. Yes, tell me.
Sir, I think my screen is hanged. I'm getting a video a little bit later, so I'm logging out and logging in back. My name is Shiv.
Okay. When you're back, let me know.
Okay, sir, I'm back now.
Okay, very good. Okay, guys, look at this diagram that I have drawn. This is the final, so this is draft final, okay, whatever we have got. What will be the shape of the water plane in this case? It is obviously at the water line. What will be the shape of the water plane? Can you visualize?
Two circle.
Two circles.
Circle.
People are telling me this, that one circle like this, one circle like this, correct? Is that what you're saying? One circle for this cylinder, one circle for this cylinder. Yes or no?
Yes, sir. Yes, sir. Yes, sir. Yes.
And this will be my 4.5 line. Yes or no? Center line of the ship, right?
Yes, sir.
Now you tell me, guys. The center of flotation is the geometric center of the water plane area. In water plane area, we have, this is only for explanation. I'll go to the working with the other sheet back. Area A1 and A2, they are identical. We know geometric center of area A1 is at G1. We know the geometric center of area A2 is at G2. Where do you think would be the geometric, where will be the center of flotation now in this case? Where will be the center of flotation?
Midway distance from G1.
Between G1 and G1.
This will be center of flotation would be here. Does everybody agree with me?
Agree, sir.
Agree, sir.
Okay. Then I'll go to that sheet. I'll draw the water plane here. Whatever I need to put in the answer sheet, I'll be doing there. On this one, I'll only be using for explanation. Tell me, beta, what is the doubt?
Can you please repeat? I just lost connection.
Okay. What I have drawn is, what I was asking is, at the final water line WL, what will be the shape of the water plane? Can you tell me?
Yes, sir. Two circles.
Two circles, okay. And what is center of flotation to you? What does center of flotation mean to you? It is the geometric center of?
Geometric center. Water plane area.
Very good. Now my water plane area comprises of two areas, this area and this area. You agree with me?
Yes, sir.
If G1 is the geometric center of this area A1 and G2 is the geometric center of area A2, and of course the distance between them is 5 meters here, we know that. Yeah. So where do you think will be the geometric center of the combined, the full water plane, A1 and A2 combined? Where would be the geometric center of the water plane area?
In the center of G1.
Yeah, so would it be at F, yes or no?
Yes, sir, correct.
Correct. Any more questions on center of flotation, guys? No? Can I go back to the working sheet then?
Right, sir.
Okay. Because it will become messy now. Otherwise, if I start doing here and there. Okay. Now what I'm making is the water plane area at final draft. For final water line, whatever you are saying. You have already told me they are going to be two circles. Center of flotation would be here, and this will be the center line, 4.5 axis passing through the center of flotation. Yes or no, guys?
Yes, sir.
Correct. Now, what will be the BM in this case? BM is equal to BMT, I'm talking obviously, is moment of inertia of the intact water plane about center line, because center line is 4.5 axis through the center of flotation. Yes or no?
Yes, sir.
Correct, beta? So it is ICL of water plane divided by volume of displacement. Correct? Yes or no? I've used the formula for BM that we learned yesterday. This will be equal to 2 into ICL of one circle. Correct? Yes or no?
Yes, sir.
Divided by volume of displacement. Correct, guys? Yes or no?
Correct, sir.
Yes, sir.
And what is the formula for, let me use blue ink there, it will go into the diagram a little bit, so it doesn't then bother us if the color is changed. What is it a center line standard axis for a circle? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, so this 2 is 2, then it is pi R4 or pi D4 upon 64, whatever you want to take.
By
Yeah.
R4 by 4.
Okay, 22 by 7. R raised to power 4 is 2 raised to power 4 divided by 4. This is I about center line of one circle multiplied by 2 divided by volume of displacement, guys. We know the final displacement. What is it? 156.629. And if I divide by 1.025, I'll get the volume of displacement. Yes or no?
Correct, sir.
Yesterday we were doing it, no? When displacement was given. Correct, beta? Yes or no, guys?
Yes.
Yes, sir.
So BM in the final condition, please calculate, is it coming 0.165 meters?
Yes, sir, 0.165.
Yes.
Fantastic. So now you have plus 0.165 BM. Please review BM. Let me know if there are any questions on BM.
सर एक बार ICL एक बार कंफर्म कर देंगे प्लीज
क्या कंफर्म करना है बेटा?
That formula, sir, I forget to about this thing.
So flip your pages, no? You don't have the notes?
Yes, sir.
Then you would have the formula with you, beta.
Got it, sir. Got it.
Got it? Okay. It is pi D4 upon 64 or pi R4 upon 4, right?
Yes, sir. Yes, sir.
About the moment of inertia of a circle about any of its diameters, right?
Yes, sir.
Okay, guys, BM all understood up to BM?
Understood. Yes, sir.
Yes.
Okay. Now, I'm sure kg does not need any deliberation. You guys should be good enough to get the kg. Kg in the final condition will be equal to initial vertical moment. That means initial displacement into initial kg. Initial displacement is 103.086. Initial kg is given 3.6. So initial vertical moment 0.86 into 3.6 plus what are the weights added? Weight added is ballast. What is the weight of the ballast? It is 51.543. What is its kg? It's written as 1 meter here already. Plus the vertical moment of the weight on deck, 2 tons
2 into
15. Divide by the final displacement of 156.629, and this gives us in one step, because we cannot weight Yeah, we cannot make kg itself a new question. 2.890 meters.
0.89.
Yeah. So minus 2.890. I put kg here. Please review kg. If anybody has any doubts, let me know. Done, sir? Done up to this place? Shall we
Yes, sir.
proceed further? Okay.
Yes, sir.
Now, yeah, I have already told you, beta. FSC final will be equal to FSM final divided by final displacement. Does everybody agree? I'm writing here on top to save space. FSC final will be equal to FSM final upon displacement final. Do you all agree with this?
Yes, sir.
FSM final will be equal to initial FSM, if any, plus minus the change. If a free surface is created, you'll add the FSM. If free surface is removed, you'll subtract the FSM. Am I right, guys?
Right, sir.
Yes,
This
sir.
will be equal to FSM initial plus minus FSM cost upon displacement final. I'm sure all of you are aligned on this part, right? Does the question give you anything about initial FSM? Can you read the question and tell me if any FSM, FSC is given?
No, sir.
Not given.
No, sir, because light ship is there already.
Okay. Light ship, but okay, fine. But it's also nothing is the question, right?
Which takes it
Yeah.
to 0.
Okay. Now look at the diagram. In this diagram, now you have taken ballast up to 2 meters. Do you think the cylinders are completely filled or there is a free surface created now?
Free surface created, so we'll add the FSM.
Yeah.
Free surface created.
So we will have to calculate the FSM cost because there is a creation of FSM. Yes or no, guys?
Yes, sir.
Yes, sir.
I go to the same diagram again. We have water ballast up to 2 meters. So here is the water ballast. Here is the water ballast. Forget about this one. Don't look at this one anymore. Now I'm saying, what is the shape of a free surface? Now, this was water plane, guys. Don't confuse the two. Shape of free surface. What will be the shape of the free surface?
Again, circular.
Again, the same. The two are coming same, never mind. But once we were talking of water plane, now we are talking of free surface. Is that correct, beta?
So what is the answer? Cylinder or surface?
Cylindrical. Surface can be cylindrical. Cylindrical is a 3D body, beta. Surface is a 2D body.
So circle is the answer. Okay.
Yeah, your glass, the free surface in your glass in front of you is the cylinder, right?
Yes.
So this free surface is a circle. This free surface is a circle. So the two free surfaces are. Now don't look at this, otherwise you'll unnecessarily get confused between water plane and free surface. Now only focus on the free surface, nothing else. Do you agree these are the two free surfaces? Correct? Yes or no?
Yes, sir.
Yes, sir.
Where will be the geometric center? Now I'll not call it as F. I'll call it as G. Understood? And
Yes, sir.
for free surface I need to draw a 4.5 axis through it. And what have we been calling this axis? Not center line, we'll call it as XX. So that there is a clear distinction between water plane and the free surface. Clear, bit?
Okay, sir.
It is the same thing, but there I have written F, here I am writing G. There I have written center line, here I am writing XX. Correct, beta?
Correct.
Yes, sir. Yes, sir.
So that there is no confusion between the two surfaces, right?
Yes.
In this case, both happen to be same, but there is complete. The two are conceptually different, right, beta?
Yes, sir.
Am I clear? Can I go to the working sheet then?
Sir,
Yeah, tell me.
sir, can you explain why this is considered as a circle? Why not a cylinder? Because free surface is a cylinder shape, right?
Beta, I am asking you, if your glass is half full, okay?
Okay.
Whatever is in the glass is the volume. But where is the surface of the water? What is the shape of the surface of the water in the glass?
Circle.
So that is the surface, no?
Okay.
How can surface be 3D here?
Okay, understood.
Understood.
Okay, so now I go back to the working sheet, and now what I am drawing is the free surface. So now I am drawing is the free surface. This is one free surface. This is the other free surface. Here is the geometric center of this free surface. And this is the 4.5 axis through this surface. Yes or no, guys?
Yes, sir.
Now, FSM caused will be equal to I about XX of what? Free surface into DI. Very good. This will be equal to two circles, so 2 into 22 by 7. Same formula again. 22 by 7 into 2 raised to power 4 divided by 4. Pi r 4 by 4 is for 1 because it is again about a diameter, and into the di. Di is 1.025, and when you solve it, it will take you back to 0.165 meters. Just see and let me know if there is any concern.
Sir, this is FSM, no? It is coming 25.771.
Why? FSM caused is this is FSC. Sorry, my mistake. How much is it coming? Sorry. Let me see in my work.
25.771.
Okay, 25 point.
771.
771, sir.
Okay, fine. Okay, 771 ton meter. Okay, fine. Okay, everybody is okay with the FSM caused, guys. Let me know.
Yes, sir.
See, please appreciate the difference between these two diagrams. Then you'll never have confusion. They are same diagrams, but they represent two different things in two different situations, right? So, final FSC will be equal to FSM initial plus FSM plus minus FSM caused divided by final displacement. This is equal to 0 plus 25.771 divided by the final displacement of 156.629. Now it will give you 0.165. Am I now correct? Correct, guys?
Yes, sir. Correct.
Yes, sir. Coming.
Okay. So the FSC comes to minus 0.165. When you take into account all these contributing factors, this gives you GM is equal to how much? GM comes to 0.149. Am I right?
Yes, sir.
Right, sir.
Yes, sir.
GM comes to 0.149, guys. So this is the GM you have got now. So GM is equal to 0.149. I have written on top. Now I have everything to apply the formula for list. So tan theta will be equal to small w 2 tons, small d 2 meters, final displacement 156.629 and GM of 0.149. And you solve it and do tan inverse, and it gives you the answer of 9.725, right? Degrees.
Sir.
9.725, guys?
Yes, sir.
Okay. Now, please review this question. Through this, you can see on this sheet, everything is clearly visible to you. And if you spread out too much of it, this question will become unmanageable. You will not be able to control it. So you need to be smart in executing your steps. And the
Only
best
to
way is,
only to find GM, there are so many steps. The rest all came in one step.
yeah, but whatever it is, but all those steps, contributory steps also, you need to be smart enough that they are closed out in one step each, BM in one, but may support them with a diagram as you are doing them, because otherwise you'll get lost, right? Okay, guys. And it is for sure MMD question. So that should also send a message that questions like this, comprehensive, which put everything to test. One list question, testing you the concept of list, testing you on the concept of law of flotation, testing you on concept of free surface, testing you on concept of kg, testing you on concept of kb and bm. Everything is being tested in this one question. Bolo beta.
The list is, I think, 10.8.
Pata nahi, I have written 9 point something. Somebody has already confirmed, I think 9.7.
Yeah.
9.72.
9.725.
You must be making some mistake, but check again, please.
9.729, sir.
Yeah, 725, 729, I don't know, but I think it is definitely not 10 degrees. Okay, so whatever it is, so look at the functions of your calculator. Maybe you're missing out on something better.
सर जो आपने FSC फाइनल इक्वल्स टू FSC इनिशियल प्लस FSC फाइनल
मैंने FSC नहीं लिखा, मैंने FSM इनिशियल प्लस FSM कॉस्ट
प्लस इसको मैं ये नहीं सकता सर FSC फाइनल विल बी इक्वल्स टू FSM इनिशियल विल बी इक्वल टू FSM फाइनल सर.
You can write that. But then you will have to say why it is, because there is no FSM given, right?
Correct, but
FSM initial cannot be equal to FSM final. There is FSM final. FSM initial is 0. How can the two be equal?
Correct, sir. In light ship condition, FSM.
दोनों सिलेंडर है.
अरे तो लाइट शिप में FSM किधर है भाई? Which tank is left in the light condition?
लोकेश पानी बाद में भरा है. Initially 0 ही है.
अच्छा ओके ठीक है सर.
हाँ. अगर पहले क्वेश्चन में FSC दिया था 0.08, अभी तक कुछ
समझ गया सर. मैं इनिशियल्स को 4 मीटर भर के सोच के गलती होगी सर.
नहीं 4 मीटर वाज द ड्राफ्ट बेटे.
हाँ जी सर वही गलती है.
4 meter was the draft. 4 meter पे what you are that final draft what you are working is BM, and what you are working at sounding of 2 meter is the free surface FSM.
Yes sir. हाँ जी sir.
Okay guys, review it more, because this is a question which has basically, and I'm happy that in this class I don't see too many concerns about understanding it. There's not much of an issue. So if everybody is okay, then I can go to the next question. Because so if everybody is okay, then I'll go to the next question, guys. Is that fine with everybody?
Yes sir.
Okay, so here is the next one. This is MMD 2020. An undivided tank of length 18 meters has the following half ordinates of the water line. When half ordinates are given, it is understood that the tank is symmetrical about that particular line, and the other half will be exactly the replica of what is given. Okay. Fuel oil of RD 0.9 is loaded to a sounding of 0.8 meters in the tank. Assume the tank to be wall-sided. Determine the kg fluid. It's an MMD question, guys. Please take note of this word, kg fluid, in the final condition if the initial displacement was 20,000 tons and initial kg was 10 meters. Now, there is a word used here, wall-sided. Assuming the tank to be wall-sided. Okay, I'll go back here again. Now, when we say a ship is wall-sided, we mean that the water plane area over the range, if you say the full ship is wall-sided, that means from keel to waterline. If you say the ship is wall-sided between 3 meters and 5 meters, then between 3 and 5 meters. So when the ship is wall-sided over the range in which it is wall-sided, the water plane area of the ship is identical in that range. Then the ship is said to be wall-sided. Is that clear, beta? Understood? The water plane of the ship shall be identical when the ship in that range when the ship is said to be wall-sided. When a tank is said to be wall-sided, what is the counterpart of water plane area in the tank? It is the surface of the liquid. Yes or no? Correct?
Yes.
So when a tank is wall-sided, see, I can only refer to wall-sided tank here and walk away, but tomorrow you'll again have this word with ship that you'll again get stuck. Tank is wall-sided means that the surface of the liquid at any sounding in the tank, from bottom of the tank to the tank top of the tank. So if the tank is, this is the bottom of the tank and this is the top of the tank. You take the free surface at any sounding. All the free surfaces will be identical. All the free surfaces will be identical. Like the glass in front of you, if you see the free surface at different soundings, at each sounding, the free surface will be circular in shape. So the glass is said to be wall-sided. Is that clear, beta?
So just one thing, if I would like to say, if you can correct me. Basically, to be wall-sided, the shape has to be symmetrical. Anywhere even slight
No,
deformation is there, it doesn't become.
Symmetry is about an axis, beta. Symmetry
I
is
mean,
about.
it has to be a proper shape, like not deformed or not buckled or anywhere.
No, no, no,
Like,
no, 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 no. When your ship is curved, then what happens? Your water plane area at maybe 2 meters is different from water plane area at 5 meters. The
correct,
ship is
yeah.
not ship is not deformed. Deformation is something a defect. Deformation is a defect, right? Maybe you are wanting to say something, but you are not appropriately articulating it. So
Correct.
it is not a deformation issue. It is a shape issue, right? Okay. So what I'm saying is, if you're talking of wall-sided tank, that means whether you take the free surface at 0.2 meter, whether you take the bottom of the tank, you take at a sounding of 0.1 meter, you take at a sounding of 1 meter, you take at a sounding of 1.5 meters, everywhere the water plane area would be identical. The idea is the volume then can be calculated by base multiplied by sounding in a wall-sided situation. Correct, Peter?
Correct, yeah.
A box shape, a cuboidal tank is also wall-sided, in which the area everywhere is, the water plane is rectangular or square, whatever it is, right? A cylindrical
Yes, sir.
shape is also wall-sided. There, everywhere it is circular, right, beta?
Yes, sir.
Okay, so that is what it is trying to say. Here the shape is curvilinear, but he says the tank is wall-sided. That's what you need to understand and appreciate. So with this little bit of discussion on wall-sided, we can go to the question now. And undivided.
Sir,
Yeah.
one thing about wall side. Sir, I understood about the tank of the wall sided, but can you please explain again about the ship, how we can relate to the ship?
Water plane area, the counterpart of the free surface in ship will be the water plane. If the water plane is identical, then it is wall-sided, right? Okay.
Water plane area at any level of the ship.
In that range of draft, sometimes it does not have to be from keel to 10 meters draft. No, sometimes you may say the ship is wall-sided between 5 and 7 meters. That means between 5 and 7 meters, the water plane areas are identical, right?
Okay, sir. Okay.
Understood.
Okay. It does not have to be right from keel to top. Yeah, it can be on in a certain range also, right? Okay.
Yes, sir.
Okay, guys. So now with this little bit thing, we can go to the next question. An undivided DB tank, length 18 meters, has the following half ordinates of the water line. Again, guys, my orientation would be you can draw whichever way you want. I'll take the top of the page as the forward, the bottom part of the page as aft. You can draw whichever way you want. These breadths are half breadths are given. So obviously the breadth on the other side would be exactly a replica of it. Fuel oil is filled up. So basically, if you see this tank is what, like it's how many ordinates? 1, 2, 3, 4, 5, 6, 7 ordinates. So basically, it is less in the forward part, then increasing from forward they are given and increasing.
So are you drawing anything by any case? Because you cannot see.
You can also draw in the meantime, better.
No, no, sir. Okay, now it is.
This is the tank. This is not the ship I'm drawing. This is the tank part I'm drawing, and half breadths are given. 7 of them. Okay. This is the center line of the tank. Need not be the center line of the ship, but this is the center line of the tank. So this is the free surface or the surface of the tank at some level. And these are 2 meters, half of them 2.5, 3.9, 5.2, 6.7, 8 meters, and lastly it is 10.1. Guys, is the diagram clear to everybody?
Yes, sir.
Okay.
Yes, sir.
Okay, first let's figure out what we need to calculate. The question says get the kg final fluid. What is it equal to? What is kg fluid equal to?
kg plus FSC.
Initial
kg
plus correction. FSC.
kg plus
Kg final plus FSC, right, guys?
Yes,
FSC final, correct? And what will be FSC final equal to? FSC final will be equal to FSM final upon displacement final, correct, guys? Am I right?
yes, sir.
Yes, sir.
Yes, sir.
Okay. So this is what we need to now calculate. We first need to calculate the kg solid. We need to see if there are slack tanks and get FSC and add it, and that will be the answer to the question. Understood? Is the scope of the question clear first before we start solving? Okay, beta? Okay. What is the initial displacement of the ship, guys? Look at the question and tell me what is the initial displacement.
20,000.
20,000 tons. What is the initial kg of the ship? 10 meters.
10 meters.
Is there anything given about any FSM initial? Not
No,
given. So I'll take 0. Correct, guys? Correct?
yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
So firstly, I'll need to get final displacement, for which I need to add the amount of oil taken. Now it is wall-sided and you have taken to a sounding of 0.8 meters. Being wall-sided, I'm sure you'll agree that the volume will be equal to area of this base multiplied by the sounding of 0.8 meters. Yes or no? Like we did in the case of cylinder. In case of cylinder, we took the area of the base pi r square into the 2 meters of sounding. Yes or no?
Yes.
So here the area of the base will be the area, this entire area which is drawn here, right, guys? This full area, correct?
Yes. Yes, sir.
Yes, sir.
Into 0.8 meters will give us the volume of the oil.
Yes, sir.
Yes or no?
Yes.
Multiplied by RD
Yes, sir.
will give weight of the oil. So, right? So weight of the oil we'll have to calculate. Second, what will be the kg of this oil? It's a wall-sided tank.
0.4.
0.4.
Because all are similar. Yeah, very good, shabash. So that will help us in getting the final kg of the ship and final displacement of the ship. Now, does the question say that the tank is slack? Has he given us the height of the tank? Yes or no?
Yes, sir.
No, sir.
He has not given us any height of the tank, right? Okay. So it may be possible the tank gets full when sounded to 8 meters, 0.8 meters. But this question does not say anything. Now there is, when the question is silent and there is something missing, what will be safer? To assume the tank to be slack or tank to be full? What will be safer from stability perspective?
Slack full.
Thank to slack.
Slack. So the question does not say the tank is slack. Unlike the previous question where it said cylinder was only 2 meters filled up, and we know it was floating at 4 meters earlier, so cylinder was much higher. In the previous question, that box-shaped vessel, the height of the TV was 2 meters and we ballasted to 1 meter. So there it was absolutely clear that the tank's free surface is created. In this question, it is not evident from the question whether it is not clearly stated whether free surface is created or not. When it is so, the safer side would be to presume that free surface is created. Am I clear about it, guys?
Yes, sir.
Okay.
Yes, sir.
So now you tell me, since these ordinates are half ordinates, do you agree that the geometric center of this free surface, this will be the shape of the free surface, then do you agree that the geometric center of the free surface will lie on this line XX? Yes or no?
Yes, sir.
Yes. Yes, sir.
Correct. So I will have to be about XX, yes or no? For free surface moment. Correct, Bete?
Yes, sir.
So then does it become a vertical ordinate case or horizontal ordinate case? If XX is
Vertical.
Vertical. And vertical, we'll have to take half ordinates, so we'll continue solving with half ordinates, will not make them. We'll make the table. Okay? Now why with half ordinates? Because you also have to get moment of inertia of this surface of this area about XX, and that can happen only when you take half ordinates. Am I clear, Beta? Correct? Guys, clear why we have taken this decision? Okay.
Sir,
So
not
now,
good.
what is it that you did not get? Tell me.
Why here taking sir half, sir?
Half is given in the question. What is it that you have not got? Tell me that.
So here area we will calculate, sir, half ordinate only.
You will make different tables for area and different table for moment of inertia, or you will make only one table?
We will make a different table.
You want to make different tables. Why? You have a lot of time in the exam, is it?
No, sir.
Okay. So, if you have to get I of the free surface, for that, look at this diagram. You have to calculate I about which axis?
Axis.
XX. Yes or no?
Yes, sir.
So if you have to calculate about XX and you take full ordinates, will you be able to calculate about XX by taking full ordinates? Yes or no? Tell me that.
We will take sir half ordinate.
No. Arey, don't say this, no. I'm asking you, if you take full ordinates, instead of 2, you take 4, instead of 2.5, you take 5. Can you calculate taking 4 and 5 and 7.8? Can you calculate I about x6? Yes or no?
Yes.
You can calculate.
We can calculate.
How? Tell me how you can calculate by taking full.
No, we will do sir half actually.
No, please.
This ordinate.
No, I'm talking to the person who said we'll calculate. Please tell me how will you calculate, beta?
No, sir, cannot produce.
Why? Now you tell me why you cannot calculate. Okay, give me the reason for that.
Because sir, we are taking sir center of the coordinator.
So, no, the answer I expected was that for I it will be a case of vertical ordinates, and for vertical ordinates it is important that all ordinates terminate at one axis, and the formulae are based on that. Correct?
Correct.
Yes, sir.
That is the logic you should have given. Am I right, guys? That is why we are taking half ordinates. Yes or no?
Yes, sir.
Yes, the ordinates are terminating at x.
Yes, so we'll work around, so might as well work around with half, right? So now please make with half ordinates the table. You will have the half ordinate here. Then 7 of them you can work by rule 1 or rule 2. I have worked with rule 2. So I will give you the answer by rule 2. Okay, I think I've done by rule 2. No, I've done by rule 1 or 2, or I've got both the answers. I don't know which one have I used. A second, let me just see which rule have I used. By 3. No, I think I've used rule 1 only. Seems I've used rule 1. Let's see. Okay, never mind. Let's use rule 1. Okay. 7 ordinates, you are at liberty to use rule 1 or 2. So let's use rule 1. If it doesn't match, never mind. I'll correct it. So half ordinate, what will be the next? Simpson's multiplier. What will this give us, guys? What will this give us? Next column.
Product of area.
Product of full area or half area?
Half area.
Half area. So don't miss out on that. Then what will be the next column?
Ordinate.
Half ordinate. Very good. This will give us product of moment
Of half area. Half.
Yeah,
Half
about
out-
XX,
XX.
about XX of
XX.
half area. Then you'll again repeat half ordinate, and this will give you product of inertia about XX of the half area. Will you directly get SOPs or you'll get summation first?
Summation.
Directly SOP, sir. Directly.
How can you get directly, beta? Who will account for 1 by 2 and 3 by 1 by 3? What's wrong with you, yaar? Vertical ordinate, now you're going back to the start line again. Correct, guys?
So you have solved with second rule, right? So you are solving second rule.
I don't know, yaar. I think I've solved by rule 1 because I can see coefficient 1 by 3 used. Let's solve by rule 1 if you want to match with me. If others are solving by rule 2, I have no issues, but I may not have the answer. Let me see my calculations. I think I've solved by rule 1. I've got this first is 94.1. I have got. I think that's coming by rule 1 if I'm not mistaken. Just see.
Rule 1, sir. 96.1.
96 or 94?
96.1. 96.1, sir. I had rule 1 says.
Yes, sir. 96.1.
Then my answers would not match because I have got 94.1. Then my answers would be out. Anyway, now mind you solve. I'll take your values. Give me a minute. Let me just. You will solve it. Let me see why did I mess it up or where did I make a mistake. Give me a minute. Yeah, 96.1 it should have come. 96.1, then 30. My calculations are wrong. I'll correct those values. I have the values correct, but I've taken them wrong, I think. It's 96.1 for the first one summation. Next is 615.37. And there are.
That is correct, sir. That is
And
correct.
4431.397. When I make them 1 by 3 and half, 307.685. And this will be 1477.132. Anybody doing by rule 2? I can give you no idea. I don't have the values for rule 2. Okay, fine.
Sir, are you sharing the screen or no, sir?
No. Why you need my screen? You should be focusing on your working, man.
Sir, from rule 1, values are verified. Same.
Yeah, they're same. I know. Okay, now I'll correct these values. I have taken down from my table. I solved, but my answers would not match. This is 96.1. This is 615.37. And this is 4431.397. So summation half area will be 696.1. This will be 307.685. And this will be 1477.132. Correct, guys? Please do it and see.
Yes, sir.
Yes, sir. Correct, sir.
Why did I press this? The correct side? Okay. So now, guys, we will get the full area. So half area, and then we'll multiply by 2. So half area will be equal to, we have used rule 1. So 1 by 3. Common interval 1, 2, 3, 4, 5, 6. So h is equal to 18 by 6 equal to 3 meters. Right, guys? Correct?
Yes, sir. Yes, sir.
So 1 by 3, the coefficient, 3, the common interval, and 96.1. So half area is 96.1 square meters. This implies full area is equal to 96.1 into 2. So 192 square meters. Right, guys? Correct?
Yes, sir.
So now, what will be the weight of the oil taken? Weight of the oil will be equal to the volume of the oil, which will be... Okay, everybody is there up to area, or somebody is still lagging behind? Let me first confirm that. Otherwise, people will miss out.
Sir, doing it, sir.
Okay, do it, and then come. Let me know once you are at par with us.
Done, sir.
Okay, done. Very good. Can we continue, guys, or somebody is still solving? You can stop me. I can wait for you more.
Excuse me, sir.
Yeah.
Sir, if we use rule 2, will the centroid value be different, sir?
Yeah, values will, the area will be different, of course, by rule 2, yeah.
Okay, sir.
Yeah, you will be able to compare only with somebody who's used rule 2 bit.
Yes.
Sorry, say again.
Now, what will be the volume of the oil? Volume of the oil will be this area. Why?
Area
Because it's the sounding, right?
Into density.
Yeah, 92 by the sounding of 0.8 multiplied by RD of oil 0.9. How many tons it comes to?
138 decibel 384.
384 tons. Small W1. How come I am written one? Achha, my area was wrong. No, that's why it was okay. So guys, this answer of mine may not match. So that will be subject to correction, of course. I'll keep correcting my notebook also. 138.38. This will give us the final displacement, guys. Final displacement would be equal to initial displacement of 20,000 tons plus 138.384. This makes it 20,138.384 tons. Correct, guys? Yes or no?
Yes, sir.
Yes, sir.
So we have the final displacement. We know the kg. Kg of this weight will be equal to kg of this small w. Kg of the small w will be half the sounding, so 0.8 by 2, 0.4 meters. Yeah, this will lead us to the kg of the vessel in the final condition. Initial vertical moment 20,000 tons into initial kg, yeah, plus weight of the oil 38.384 into kg 0.4 divided by the total displacement 138.384. And how much?
964.
9.9.
9.934.
Okay, 9.934 is the kg final. Is everybody good up to kg? Let me know.
So this is what we got is kg final, right?
No, yeah, this is kg final solid, not the answer. Answer wants fluid
Ah,
kg.
kg fluid.
Yeah, so kg final is 9.934. This is solid kg. This is not the answer. Correct, guys?
Yes, sir.
Okay, now we have to get the FSM cost because initial FSM is not there. So FSM cost, initial FSC is not given. Had he given initial FSM or FSC, that would have been required to be factored in. So FSM final, I can say, will be equal to FSM cost. Why? Because there is no initial FSM. Right, guys?
Yes, sir.
And in this case, that will be twice of what you have got here. So rule 1 we have used, coefficient 1 by 3, common interval 3. SOP inertia is 1477.132. This is for half the area, beta. And you multiply by 2, it will become for the full area moment of inertia. And this comes to 4, 6, 2, 14, 15, 9, 2. 2954.62264 meter 4. Right, guys? FSM final. Correct?
Yes, sir. 2954.264.
Correct. We have got it for half and then we doubled it up. This is for doubling up, right?
Yes, sir.
Okay. So this will give us FSC final. FSC final would be equal to 2954.264 divided by the final displacement of 20,138.384. How many meters
सर
was
उसको
that?
डेंसिटी से मल्टीप्लाई नहीं किया सर
Okay, my mistake.
सर
FSM
डेंसिटी से तो मल्टीप्लाई नहीं किया
My mistake.
इसको
Okay.
0.94 आएगा.
Okay. Complete the step up. FSM will be 0.9 also. So what will be this value? Correct this value then.
2658.837.
2685.83.
2605
2605.
26058
2605.838 ton meters now. Okay.
yes sir
So this will be 0.9. I
No, sir,
multiplied.
I'm getting 2658.
2658
2658.
2658 decimal
838.
838 ton meter. Okay, this seems to be correct, beta. 26, because it will not reduce by that much. You are only multiplying by 0.9. Okay, so the final FSC final will be equal to final FSM 2658.838 divided by final displacement 384. How many meters is the final FSC, beta?
0.132.
132. Okay. What was the kg final? 9.334. So kg fluid in the final condition will be sum total of this 664.9. So 9.466 is the answer, guys. You can ignore my answer. That is obviously wrong then. That's obviously wrong. My answer is wrong for sure.
So just one question I wanted to ask.
Yeah, tell me.
This is related to very initial steps. So in the bracket you have written this formula kg fluid. Just by looking out the question, how can
SBI का करना होगा ईमेल बहुत है हाँ
The surface, the free surface in the tank will be same at all the soundings, from
Free
base,
surface.
from the
Yeah.
bottom to the top, right, of the tank.
Okay. I just wanted this. Okay. Thank you.
This is the not last batch, last to last batch actually. A floating dry dock has a DB tank of depth 4 meters and width 44 meters. The vertical sides are tanks on either side, which are 4 meter wide and are above the DB tanks. If the draft of the dry dock is 8 meters and kg 4.5 meters, you have to calculate the GMT. So let me just help you with the diagram first. The diagram, the dry dock is 44-meter wide. So we are making the cross-sectional view. Okay, we are not making the longitudinal view. We are making the cross-sectional view. This is 44 meters of breadth of the thing. It has this DB, which is 44-meter in width. Of course, it will be subdivided. That's another issue. And they are is 4 meters. So half of the DB is 4 meters. And then on the sides, you have tanks. These tanks are 4 meters wide each. You have another tank on the sides here. This is also 4 meters. And this is the space where you'll have the dry dock, you'll have the center line blocks here, you'll have the side blocks here. The ship will come and later on sit like this. Correct, guys? Can you appreciate the diagram? You don't have to make the ship. But once I made the ship, now can you appreciate the diagram, right? Okay. So basically, it is now he said that the vertical sides on this are side tanks 4 meter wide. Length is not given, so you can take any length L. Length can be anything L. Okay. And if the dry dock is at 8 meters, so it is so obviously it will be above the DB somewhere here. This is the water line. Find the GM of the vessel. kg of the dry dock is given as 4.5 meters. GM is to be found. We already know GM is equal to km minus kg, right? So this will be equal to km is equal to kb plus bm minus kg, and of course minus FSC also, if any. So you'll have to calculate these components. Give it a try. I've given you the teaser for homework. I got this answer. You can try and see if it matches. Would you like to try it, guys?
Yes,
It's a regular.
Okay, sir.
Yes, sir.
Okay. So
Yes,
try
sir.
this. Yeah, try this. You can take down this question and take the answer. With this, we come to end of. If you are taking down, I'll come back to it again. No problem. With this, we come to end of it. That finishes our moment of inertia and its applications. I have tried covering all that I could in different ways. Now, if you have understood this much, and if you can apply what you have understood, then even if the questions change, they should not bother you. Reinforcement of the concepts. So, with this, I come to end of one topic of yours, moment of inertia and its applications. Now, if anybody has gone through past papers in earlier attempts or feels that anything has been left uncovered in this topic, you're more than welcome to bring that up. I'll touch upon that also.
Excuse me, sir.
Yeah, tell me.
Sir, one question is there.
Yeah, tell me.
Sir, in CL Dubey, question number 7, they say
I neither have CL Dubey nor do I remember questions by number. Please tell me the question.
they mentioned a deep tank bulkhead is 6 meters height. The half ordinates of the bulkhead are at equal intervals, commencing from top at 2.82, 2.54, and 2.26. That is 3 ordinates given.
Okay.
Calculate the thrust on the bulkhead when the tank contains salt water to a depth of 3 meters. So total height is 6 meters and they are still 3 meters.
Okay, so then now you tell me the ordinate. One second. How many ordinates are given?
3 ordinates, sir.
3 ordinates are given. So give me the full ordinates. Don't give half ordinates. Give me the double करके बोल दो.
So 5.08.
5.08.
Sorry. First one is 2.
Lower or bottom? Upper or bottom? Beta, it is from top.
Top one is 5.64.
5.64 is the top one. Okay.
Middle one is 5.08.
These are full ordinates, right? Okay.
Yes, sir, full ordinates. And bottom one is 4.52.
Okay. What does he want you to calculate?
Water level is still 3 meters. That is
water level is here, right?
Yes, sir.
So what is the problem? What does he want you to calculate?
Thrust on thrust.
So what is the issue, beta? Calculate this area by rule 3 and calculate the geometric center of it. So for 5, 8, minus 1, it will be 5, 8 and minus 1. And that will give you this area. Correct? Can you calculate this area by rule 3? Tell me. If you have a problem, then I repeat rule 3.
No, I tried with rule 3, sir. 5, 8, minus 1. Mein.
Yeah.
And CG I'm getting around 14, sir.
No, it can't. No, you have not used 3, 10, minus 1 then. That's one. Okay. Let me just clear this one. And can I clear this board and do this question with him, guys? I'm just clearing it. Have you taken down?
Yes, sir.
Okay. Now, you'll have to repeat the values once again. I don't mind taking them here. So the upper one is 5.64. Okay, 5.08 if I'm not mistaken, is it?
Yes, sir. 5.08
and
4.52.
4.52 and H is 3.
H is 3.
And here is the liquid level, right? That's the question, right? This is the immersed area, no, beta?
Yes, sir.
Okay. So the immersed area A will be equal to 5, 8, minus 1. Coefficient for rule 3 is 1 by 12 into 4.52 into 5 plus 5.08 into 8 minus 5.64 into 1. Can you calculate this area and give me how many liters is the immersed area?
24.28.
24.28. Are you okay up to this place, this point, beta?
Yes, sir.
Okay. Then to find the moment, we'll have to use 310 minus 1. When we use 310 minus 1, we will get the moment about this axis. Correct, guys? Those who have recently done with me would understand that this will give you moment about x-axis, right? About this ordinate, right? Correct? So moment about x-axis of this area will be equal to coefficient h by 24, h is 3. So, 1 second, have we multiplied one by common interval? Did we multiply by 3? No. Just see.
No, 14.4 आएगा sir. If we multiply with 3, 3 is not
Yes.
multiplied.
So how much is 14.4? 400. Okay. It is coefficient into common interval into SOP, right? Right,
Yes.
guys?
Yes, sir.
Okay. So moment about x will be 3 by 24 into common interval 3. Some of you may be doing h square by 24. It's up to you. Into 4.52 into 3 plus 5.08 into 10 minus 5.64 into 1. How much does this moment come, beta? This will be cubic meter, will be the units of it. How much does it come?
Yes, sir. So 179.94.
94, okay, 0 meter cube, okay. Now when I divide this moment about xx by the area, I will get the distance of the GC from xx. This cannot be 174, is it 174? Just see.
22.02.
How much?
22.02, sir.
It cannot be that much here. It cannot be 179. Check again, don't worry. Take your time, no worry here. Don't worry. Check again, please. Because your display dxx cannot be more than 3 in any case here. It has to be 22.02, okay? So dxx will be equal to 22.02 divided by 14.400. How much does this come, beta? dxx?
1529.
1.5.
Okay, very good. Now for thrust, we need distance from liquid level. We don't need from xx. So DLL will be equal to 3 meters of sounding minus dxx 1.529. Am I right?
Yes, sir.
How much does this come? 19794 and 1.471?
Yes, sir. 1.4.
Yeah, so now the thrust will be equal to, is it seawater or something else?
Seawater into 1.025.
Into the seawater 1.025 into the area of 14.400. If now also it is not matching, then the answer is wrong. Okay.
The same, sir. 21.7.
21.70971.
Okay. Now if it is matching, if it is matching, good. If it is not matching, then answer is wrong. Okay, that's what it is.
Sir, I just had one more doubt. Like if there is one more ordinate added up, this is 3 ordinates, we can use this rule 3.
Well, then you use 141
Okay.
Where is the ordinate? You see, you have now out to create confusion. Add one more ordinate. Add where? In the immersed part or non-immersed part? You are just now creating confusion for yourself and everybody else now.
No. My doubt is like if they give one more ordinate and give some other draft, then just for an example, sir, I'm asking.
For example, what? Give me the example, no?
Like suppose one more ordinate is on top of 5.64. Suppose some 7. And draft they have insert some 8 meters.
How can they give you 8 meters? Well, yesterday also somebody asked me this question, and I said, then is the Simpson's rules applicable when they are not equispaced? If the draft is 8 meters, then you need this width. Then are they equispaced? then ordinates are not equispaced, no?
Yes, sir.
Then how can Simpson's rules be applied?
Okay.
Simpson's rules itself will fall flat, no?
Yes, sir.
Okay.
Okay.
That is a prerequisite condition for Simpson's rules, that the ordinates of the area or volume of interest should be at equispaced intervals. Yes or no, guys?
So that means if they give some sort of this question, then the draft will be exactly equispaced places.
It has to be, yeah. It has to be.
Okay, sir.
In this question also, he wanted you to use rule 3, and there is no formula for moment of inertia for rule 3. That's why he's not taken you to COP. He's shied away from that, right?
Yes, sir.
Right? So that's what it is.
But the rule 1 can be applied here, correct?
Sir, this can be done in one more way, sir.
Which is the other way, yeah?
Like bottom portion, we'll consider it as a trapezium. The above portion is 5.08 and bottom is 4.52.
How can
height is
but how can you consider it trapezium? If you consider it trapezium, then the error will depend upon, because you're treating it as a straight line. If you want to change this thing into a trapezium, then the error will depend upon how much is the aberration. You are saying I'll treat it like this. Let me change to blue. Now you are saying I want to treat it as a trapezium, then the area would be out by this much, whatever it is. You are saying this is the shape you are taking. What about the areas which are left out? What about these areas which are left? And they can be different depending on the curvature. What about these areas?
Yes, sir.
Who will address them? Correct?
Because I tried with this trapezium method, I was trying out with the Simpson's method, I did not get the answer. The trapezium method, I got the answer, 21.7.
That depends, no? How much is the curve closer to the straight line? If the curvature by luck is closer to the straight line, the error may not be much. But if there is a huge aberration, then there will be error, no?
Yes, sir.
Even by trapezium, you would not have got exact answer. You may have got a better answer, but not exact answer, right?
No, 21.712.
So you will not get the same answer. That's what I'm telling you. How much is the error? That depends. How much is the curve deviated from a straight line, right?
Yes, sir.
Okay.
Okay, sir. Thank you, sir.
Okay, guys. I'll sign out then. Done for the day. One topic done. And tomorrow we start with bilging. Okay.
ठीक है सर.
See you tomorrow.
Sir.
Bye, guys. Bye.
Guys, is anyone online right now? Hello.
बोलो भाई.
हाँ राजकुमार, ये क्वेश्चन के न्यूमेरिकल्स किधर से करने यूजुअली, कहाँ से पूछते हैं?
क्या चीज के?
ये टॉपिक के न्यूमेरिकल्स प्रैक्टिस करनी हो तो कहाँ से करें?
अरे भाई सर जो क्लास में कराते हैं मैं उसको रिपीट कर लेता हूँ, बाकी पास्ट पेपर देख लेता हूँ जैसे फेज 1 में किया था, और कुछ नहीं कर रहा हूँ फिलहाल.
अच्छा, क्योंकि CL2 में कोई कर रहा है इसलिए पता नहीं.